In this video, we will cover the concepts of maxima and minima, also known as the extrema of a function. Extrema occur at places where the graph changes behavior, meaning the points where a graph changes from increasing to decreasing or from decreasing to increasing. Let's first define terms. An absolute maximum point is the point where the function obtains its greatest y value over the specified domain. Similarly, an absolute minimum point is the point where the function obtains its least y value over the specified domain. We can also refer to the absolute maximum point as the global maximum point and to the absolute minimum point as the global minimum point. A function cannot have more than one absolute or global maximum. The same is true for absolute or global minimum. We can also say that the absolute maximum point is the highest point on the graph of a function and that the absolute minimum point is the lowest point on the graph of a function. There are also cases where no absolute maxima or minima exist. You will see some examples of this later. A relative maximum point is a point where the function changes direction from increasing to decreasing with respect to other nearby points, making that point a high point in the graph. Similarly, a relative minimum point is a point where a function changes direction from decreasing to increasing with respect to other nearby points, making that point a bottom in the graph. A function may have more than one relative maximum over a specified domain. The same is true for a relative minimum. If a function has several relative maximum points, we can say that it has several relative maxima, since maxima is the plural form of maximum. And if a function has several relative maximum points, we can say that it has several relative minima, since minima is the plural form of minimum. Relative minima, or maxima, are also referred to as local minima or maxima.
How do I know if a point is higher or lower than another point?
Saying a point is higher or lower than another is indicative of the y value of the point. If a point is higher than another, then its y value is greater than the other's y value. If a point is lower than another, then its y value is less than the other's y value. For example, if a point has a y value of 10 and another point has a y value of -3, we would say that the point with the y value of 10 is higher than the point with the y value of -3. Let's look at this on the graph. Notice how the graph is increasing to a point where it then begins to decrease. It then decreases to a point where it begins to increase again. We call the point where the curve stops increasing and begins decreasing the relative maximum point, and the point where the curve stops decreasing and begins increasing the relative minimum point. We can see that the relative maximum point and the relative minimum point are not actually the highest and lowest points on the graph, since there are points to the left side of the graph that have a smaller y value than the relative minimum point, and there are points to the right side of the graph that have a larger y value than the y value at the relative maximum point.
Are we assuming that this graph continues downward forever at the left side as the x values decrease in value, and that this graph continues upward forever at the right side as the x values increase in value?
That is a good observation. Yes, you are correct. The reason why we are interested in relative minima and maxima is because those are places where the graph changes behavior from increasing to decreasing or decreasing to increasing. Now let's talk about absolute extrema.
So would the absolute minimum point and absolute maximum point be the points on the graph that are higher or lower than all the other points on the graph?
Essentially, yes. For example, on our graph above, we do not have an absolute minima or maxima as the graph continues to -infinity and positive infinity, but if we were to describe the graph on a specified interval, we could determine the absolute minima and maxima. Let's say we are evaluating the graph on the interval of -2.5 to 1. This means that there will be endpoints at x equals -2.5 and x equals 1. Now we can determine the absolute minimum and absolute maximum points based on which points have a greater and lesser y value. It is clear from the graph that the point with the lowest y value is at the endpoint x equals negative 2.5, and the point with the highest absolute value is at the endpoint x equals 1.
Can there be relative minima or maxima at an endpoint?
In order for a point to be a relative maximum point or a relative minimum point, we must be able to look at the function values on both sides of the point that we are considering. This means that the relative extrema cannot exist at an endpoint. However, absolute maxima and absolute minima may exist at endpoints.
Can there be an absolute minima or maxima at a point that is not an endpoint?
Yes, let's look at an example of a graph where this occurs. We can see here that the graph increases to a maximum y value of 3.5 and then decreases again. Remember that when we have a graph like this one, we consider it to have no endpoints. When we describe this graph, we say that there is an absolute maximum at x equals 1 and that there is no absolute minimum, no relative maximum, and no relative minimum.